So in this video, I'm going to talk about integrating and multiplying by a strategic fraction to help you integrate. So I think this is easiest to see if I show you two examples together, because both of these actually we want to multiply by a strategic fraction, but there's like a different reason why. So for this first one, well, actually, before I go into anything, so for both of these, there's no way to integrate these as is. They're going to require manipulation, and you can't like nicely choose something to substitute because your du is like nowhere to be found. So since these are both being added, I can't easily like substitute. That kind of tips me off that I'm probably going to have to multiply by something creative. Now, in the first case, so there's no way for me to also simplify this any farther. So this fraction is what it is. And so that's going to really dictate what choice I'm going to make. But for the second fraction, so I just want to like note this. This second fraction I can rewrite as shown, right? So this becomes 1 over cosine x plus sine of x over cosine x. So these are actually two kind of different situations, because this fraction to me, this has denominators. So when I can't simplify any farther, like you see here, there's just nothing else for me to do. One really good trick to try is to multiply by the conjugate versus the other one. So since this has denominators, let's just clear the denominators. So let's multiply the top and bottom by the cosine of x. So now let's jump into both of these. So like I said, so I'm going to multiply this by the conjugate. So I'll just show you that. Okay. And so now I'm going to go ahead and multiply this out. So this becomes 1 plus sine x over 1 minus sine squared x dx. And so from here, now this is just screaming for me to rewrite the bottom using the Pythagorean theorem. So that is this little fact right here. So the denominator here can be rewritten as cosine squared x dx. Okay, so now this is a little bit of a different problem, but we still can't use substitution with this. So now we just got to think a little bit creatively. So I can't use substitution because I have this more complicated denominator on top. So when you have a fraction like this, sometimes it's good to, I've been waiting to use this phrase. Sometimes it's good to divide it up and conquer it. Okay, sorry. So let's talk about what that looks like. So I'm going to rewrite this as 1 over cosine squared x dx. And then this other one's going to be sine x over cosine squared dx. And now these are kind of two different beasts. So let me clear some space. Okay, so now when I think about this I want to rewrite one more time. So this one can be rewritten as secant squared x dx. And then this one, maybe I'll rewrite it. Let's see. Actually, how can this be rewritten? This one I can rewrite as, let's see, 1 over cosine x and then sine x over cosine x dx. Okay, so now let's see. This has an integral, right? The antiderivative of secant squared is just tangent. So this one's done. Cool. And then this one, so 1 over cosine is secant x, and then sine over cosine is tangent x. So check that out. Now I just played around with this. I just still didn't have to use like substitution. Now you might be saying, could I have used substitution? You totally could have set u equal to cosine of x and solved this whole thing, and you would have eventually gotten the same result. This is just a slightly more efficient way to get there because I didn't have to use substitution. So this becomes tangent x plus, and then the antiderivative of secant tangent is secant. So there you go. And now for the other one, so we already talked about what we want to multiply this by. So let me just rewrite this out in that form that looks a little nicer to multiply with. Okay, so here's where I'm at. So now when I multiply this, so now my top is just cosine of x. And then let's just think about what happens on the bottom here. So I'm really distributing this to these two fractions. So when I distribute cosine to the first fraction, that just becomes 1. And then when I distribute cosine to the second fraction, that's going to be sine x. So here's what I'm left with now. And now I just have to think about what do I do from here. Now, in this case, I can actually pretty easily use substitution. So I'm going to set my u equal to 1 plus sine x. And then my du is going to be cosine x dx. And so look at how nicely that all substitutes out. So this is now going to turn into du over u. And so this will ultimately equal the natural log of u, or the natural log of 1 plus sine x plus c. So there you go. And actually for this one, yeah, I guess you can leave the absolute value, or you can drop it, because it'll always end up, well, I guess it depends on the value of x. Okay, so we'll just leave it at that. So if you found that helpful, please consider hitting the like button. And so that takes care of that. So I'll catch you guys in the next video. Thanks for watching.